In this week's video, we're going to be going over the fifth lead coding problem, longest palindromic substring. Let's get started by reading the problem statement. Given a string S, find the largest palindromic substring in S. Let's get started by taking a look at three strings. So for the first string, race car, we know that the entire string is the longest palindromic substring because it reads the same as it does forward and backward. For the second string, we know that BBAB is the longest palindromic substring. Again, it reads the same forward as backwards. And of course, for Google, GOOG is going to be the longest palindromic substring. So for the initial solution, the brute force solution, what we can do is find all substrings of the string that we're given. In this case, find all substrings of Google. And once we find all those substrings and say store them in an array, here are the substrings of course, we can check if any of them are a palindrome or not. So finding all of these substrings is going to take O of n squared time because we're going to have to go through and iterate in a nested for loop manner with the I and j variables. And once we find all of these substrings, we're going to check if any of them are palindromes. Now, so for each and every single substring, we might have to do another comparison check. And so the big O time complexity of this is going to be O of n squared to get all substrings and O of n cubed to check if all of those substrings are palindromes or not. So the total complexity is actually going to be O of n cubed. Now, let's take a look at the space complexity. We're going to be storing every single substring. So that's going to be O of n squared, and that's also not good. And what makes us wonder is, can we do better than this? And of course, the answer to that is yes. Yes, we can do a lot better. Let's start with the word Google again. Now, at each index of the string, we want to have a left and right pointer, and we want to keep moving the left pointer to the left and the right pointer to the right as long as the two characters at the indices of the string are the same. So in this case, we're going to have G when we start at G, empty string when we start in between G and O when we start at O, and when we start in between the two O's in Google, since we're going to continue going left and right as long as the two values are equal, we're actually going to get GOOG. And that's going to be the general solution for this problem. We're just going to have two pointers that iterate to the left and to the right as long as the two characters are the same. Cool. Let's get into the big O of this solution. So now let's get into the big O of this solution. Let's start with the time complexity. We know that this is going to take approximately O of n squared time. Why is that? Because we're going to have to iterate at most through the entire length of the string. So that's going to happen when we're at the middle of the string. In the worst case, all the values are the same, and so we might have to do something that resembles a computation that takes 1 plus 2 plus 3 plus 2 plus 1. So it's going to be the middle value is, if the entire string is a palindrome itself, the middle value might be as long as length n, and so that's going to sum up to big O of n squared. And in terms of space complexity, we're going to be in constant space, O of 1, which is a huge improvement from our solution from before in terms of time and space complexity, because we only need 3 pointers, 1 pointer for the string and 1 pointer or 2 pointers for the indices. Cool. Now let's get into the code.
So now that we understand the algorithm and have gone over the big O, let's take a look at the code. Starting off, we have the definition of the function, which is longest palindrome, which takes in a string. Initially, we're going to be using a base largest palindrome, which is just going to be empty string. So if there is no largest palindrome, we can just return the empty string. The next thing we're going to do is iterate through the entire string in a for loop by keeping track of the indices. And now the next two steps, very important, figuring out the largest palindrome that is either of an odd size or of an even size. What we're going to need to do is pass in a string, so we can just pass in the entire string that we've gotten from our definition of the function, and we can pass in two indices. One is going to be the left index and one is going to be the right index. So here, right, when we're looking at the odd and even, we know that if we start off at the same index, we know that we are checking for the odd string, and if we start off at an index that is one more, then we're going to be looking for palindromes that are of even size. I want to take you guys through this function, largest palindrome at index, so that you guys can understand what's going on inside. So here we take the string, we take the left indice and the right indice. So we're going to be starting off by having these two indices, left index and right index, set to 0. These two variables are going to be what's going to hold the results. So when we return the palindromic substring, we want to start at the left index and end at the right index plus 1. Cool. So we want to go through a while loop. So when we start off checking for the palindrome, we want to make sure that we don't go past 0 when we're going left, and we don't go greater than or equal to the length of the string when we are incrementing right. So what we're going to do is slowly iterate by saying left minus equals 1 and right plus equals 1. So this is going to kind of expand our palindromic substring from the index that we're given, the left and the right, and that's how we again manage to get an odd palindrome and an even, is by passing in the same index for the odd and a different index for the even. A different index that's one off, of course. So yeah, so this main loop is, the whole point of this main loop is to just iterate through these left and right indices, and as we're doing that, we want to make sure that we want to iterate as long as the character at left's index in the string is equal to the right's index of the string. So if they are equal, then we know that we can update our placeholder variables, left index and right index. And at the end, what we're going to do is going to return the substring from the left index to the right index. And so this method is going to give us the largest palindromic substring at a given index, where the given index is the middle of that substring. We're going to go left and right from the middle of the substring. Cool. So we're going to have our odd and even palindromic substrings. We don't know which one is bigger, so this line is just going to determine which is the larger palindrome, whether it's the odd or the even. So here quickly, if the length of the palindrome odd is greater, then we return the palindrome odd, otherwise we return the palindrome even. And finally, so we're going to compare the largest palindrome that we've seen so far with the palindrome that we just got in this iteration of the loop. And if the larger palindrome is larger than the largest, then we're going to set that to the largest. And of course, we're going to return the largest palindrome. Alright, so now let's run this code and see what happens. And again, we get another acceptance. Thanks for watching. See you guys next time.